Hello everyone. Now we're going to study about what is data analysis. Introduction to data analysis. We all are in a common world and where we're going to study about what are the excitation about the data analysis. So we have a clear common misconception between right of the bat and the left of the bat. You don't need to be configured out. So similar to that, we're gonna study about what is data analysis, what are the visualization in data analysis, and how we gonna overcome that. So it is a process of cleaning, transforming, and modeling data to discover useful information for business decision making, and also about a massive amount of unconstructed information is also there, which is to be key insight of it. The main purpose of data analysis is to extract the useful information from data and taking out the decision based on them as an analyzing part. These insights we can cover off like they are of enormous valuable for making a decision of it. Okay, at the all the variables you can form out. So a similar example to data analysis. Now we all know we are on a surrounding basis, so we know about how data analysis we can say about. A simple example for data analysis is like whenever we take any decision in our day to life. Okay, so we think about it. Suppose I need to start making a project. Okay, so I need to think about that project, what basically that project would be all about. Okay, but thinking that it would be happening like what I chose the prior, what I am gonna do the now, or what I'm going to do in the future part. So this is a decision I'm taking. Okay, there's nothing but analyzing our past or future and making the decision based on it. Suppose if I'll say that I need to make my career, so what career I need to make? I would like to think about what is my past, what is my present, what was my past, what is my present, and what will be my future. Okay, based on that, I would make a decision of it, like what career I would choose or choose for my betterment. Okay, so this is just a decision I'm just making. So that is nothing but a data analyzing I'm doing it. So same with analyst does the business purpose, and that is what it is called the data. And what question it comes actually to your mind while making a data analyzing part in your day-to-day life? Okay, now if I say that I need to analyze that data. Okay, analyzing the data, there are different techniques of analyzing the data. The very first we have as visualization of a data in the line plot. Now, what is a line plot? We all have studied in our fifth, sixth classes or any of that. The what are the visualizations of your data? So the what is your line plot? So line plots defines the data which is taken at the specific intervals. Okay, add a line chart or a line plot. Both of the line has a curve graph, and it is a type of chart which displays the information as that series of data, basically as in data points also we can mark, and that is known as the markers. Okay, and that data is taken from a specific interval. Suppose if I'll say that I'm gonna have my meal at 10 o'clock, and after that 10, 11 o'clock, 12, so I'm taking a specific intervals of 1 hour. Okay, any other visualization of your data. So a scatter plot is used to understand the distribution of our data, as well as there is a relation between two variables, and it helps us to find out the outliner as well. So it is a type of a plot, or we can say the mathematical diagram using the Cartesian coordinates to display out, and these all the points are coded. Okay, and one additional the variable can be displayed in that. We have the types of scatter plots also, but that are not much common. We don't use much in that, but just to remember what are the types of scatter plot. There is the positive correlation, negative correlation, then we have no correlation, and that no correlation we know known as an the none part. Correct. And we have a two independent one independent and another one is a dependent variable. Okay, and suppose we have in this as in scatter plot, we are making a relation between sales and temperatures, correct? So here we had a scattering the plotting. The scattering the plot means like we are being mentioning the whatever the plot it is by the help of the dots, and there are the not fixed one or any other that are scattered, like these are not in a single line or we can say single axis or any of that. These are particularly distributed, we can say. So now comes a histogram. So this is the very like familiar to our representation we used to make in our old classes also, like the make a histogram graph or any of that, just similar to that. So it tells us the frequency of occurrence of attributes in our data which are defined as in range. Okay, and in histogram we have a linkage bar. It doesn't start from a zero itself. It has a link, so it started by the next to link. Okay, now comes is the heat maps. I know that it is a very new to you, the heat maps, what actually the heat maps are. So the heat maps are the matrix kind of visualization which is used to represent or used to compare the two variables of data and their respective values. So each element is denoted by colors and with their various intensities according to value. Suppose we have used over here the orange color and the we can say the various intensities of color is there in the orange. So either we can use any color. I can use the green color, I can use the black color, then any color. Okay, this is only to represent the values, the two. It is to the compare the two variable of the data and their particular respective values. Okay, so each of the element is denoted by colors only. There is nothing like we have to represent every donation of your variable in a color form. And a heat map is a 2D representation of your data in which the values are represented in a colors part, and moreoverly it is a visual summary of your information, and it is also looking good, like we are generally attracted to the colors, so it is generally look good also when we used to have a heat maps and this. So now comes as your box plot. What is a box plot? So it is a little very understanding topic about the box plot, but we know about the what is a box plot actually about. So in a box plot, we also write as in box plot singly, or we used to written the box plot as in parallelly. Okay, so it is just a method or for a graphical representation or the demonstration that locally it can be spread out over the most of the genuine part of the groups of the numerical data also through their qualities basically. So helps us to get the statistical details about the data such as interquartile range or any of that in which more of the data lies in the detailed form. And if I'll say that there is an example of the box plot, like we have a box, okay, and we have a whisker plot in that. So we have to display the five number summary on a set. So we use this five number summary set as a minimum, the first quartile, the lower quartile, the smaller value, the median, the upper quartile, the largest value in that, and all that. Okay, so it will have the vertical line throughout the representation of your data. So in bar chart, so bar chart is defined as the various categories of the data and their representative value in that, respective value in that. So if I'll say that I have done a comparison between reserves and any city's names that we can say, or the state or the country's name we can say. Okay, so these are the like the dependent value and the independent value. Okay, the representation of dependent x's and the independent x's on that. So there is few things to learn about what are the missing data in that. To deal with the missing data, we finally use a few algorithms in machine learning. Suppose like we use the KNN, we use the random forest, we use after that we use the removing the data from the missing value. See if your data is fulfilled, okay, and if I'll say that this is a box and this has a capacity of 5 liter. Okay, and a bottle is there, it has a capacity of 2 liters on a 5 liter, so it cannot be filled more than 2 liters. Okay, because it has a brim point, it has a capacity of it. If I'll say that if I have mixed the water and oil together, so we don't have any uses of the oil and the water together because it has none of use, so it is just a wastage of it. So similarly to that, if the data, we don't need the data which is not the helpful to us, we can remove that data, and also that we can remove the data which is unwanted or unweighted in that. So similarly, we can replace the missing value also as a feature of mean, median, mode, or any of that which is not required or it is required in a feature of your data set. So comes is one, what is one hot encoding? So one hot encoding as a comparison of categorical features into the binary part, and it is much more used in the data set, in our data set, whereas we need to have in digital circuits or any of that. And one hot encoding is also defined as an essential process of converting the categorical data values to the to the provided values we can use, and also to improve the basic prediction of it, whereas we can use that prediction in a formulation part of the classification and accuracy of a model or any of that. Now, similarly to one hot encoding and in target encoding, these are basically the same as an off, but in target encoding, that is just a process of replacing a categorical value with another mean of the target variable in that, and we calculate the mean of the data or the target variable for each and every category, and it used to replace the category variable also with the mean value. And in case we don't find any categorical target value or the variable, we use the posterior probability of that target replaces each target in that, or any non-categorical column are there that are automatically dropped out of the target encoder model. We can also use the target encoding to convert the categorical column to a numerical value in that. Now comes is what is standardization. Now, standardization is also important because we know the standardization has an particularly a great part. It is just an find to just it is just to find a rescaling of the feature value. Okay, and in the feature value we cannot use the values as in terms part. Okay, and in the data set also we have a properties of standard normalization, that is mu should be 0, sign should be 1 and all. Okay, and also the data standardization, it is a rescalable also to the attributes wherever it is, and they mean is 0 and their variance is 1. This is a property of standard normalization or the standard normal distribution, as a new mean should be 0 and the variance should be 1, and the formula to be used for the standardization is z no z bar z sigma, you can then z minus mu, that is sigma, and that is particularly mu is a mean and the sign is just standard deviation in that. Okay, and it should be the mean should be 0 and the standard deviation should be 1 or the variance should be 1 in that. So we have a support vector machine also that is used to try basic maximization in the distance between more of the often part is an off, and basically it has a feature of a very large values, we don't have a small values in that. So the graph for moving a standard deviation or the standardization is this: raising from a 0 value, getting a hike, and after that being a constant in the particular part, after that again depreciating in a particular sentence in that. So now what is a normalization? We studied about the standardization, we studied about what is the use of standardization. Now we will get toward what is normalization in machine learning, we can say. Okay, so in machine learning, normalization is the process of translating the data into the range of 0 to 1 or minus 1 to 1. It is just a particular range of the values to some standard range in that. It also help us to speed up the training process in that. So basically the every simple transforming data, it is converted to a software in that. And some of the machine learning algorithm benefits the normalization at the great extent, and that often the standardization also do, but particularly when it is come to a Euclidean distance or any of that, so normalization is particularly we can use in that. So what is the formula of normalization? It is x minus phi the score min, and after that the max to min. Okay, it is cancellized to the max to the min. Okay, and it is a very particular feature of it. And what exactly you need to require it is it have a different ranges. The ranges are not fixed in that, and also the scale of the data set is not fixed in that. It has a range of values. It has a distorting differences. It has an every set does not require the normalization actually. So the graph for normalization is this. The normalized to 0 to 1, and after that we have a degree of affirmation in that. So what if like we use the algorithms in normalization? The algorithm is just to scale the technique in which a value are shifted and rescaled so that they can reach to a particular range between 0 to 1. Also we can use the 0 to 1, or we can shift to minus 1 to 1, because it is just to normalize the data. Okay, there is some conditional part where the data is not normalization. You need to normalize that data, and it depends upon the data at how much extent it used to obtain. Now, what is the data imbalance? Okay, these are the basically a terms, or we can say introduction about your data analysis, and basically there are the problems we used to come upon, and we need to solve also. So in the data imbalance or data imbalance problem, it basically comes upon to save your more of your data. Okay, and data imbalance techniques are also there. We need to approach. We need to resample. We used to re-get that data in a particular form. Creating the synthetic data using the algorithms such as SMART, the abbreviation SMART, the synthetic minority over the sampling technique. Okay, and its performance is matrix based, such as F1 score, confusion matrix, or ROC curves. Okay, and basically it is just the basically it is just an imbalanced class distribution, which is a scenario of number of observation belonging to one class significantly lower than those of the belongings to another classes. So basically trying the different machine learning algorithm which are good at the handling data balance. It is also like, suppose if I'll say give you an example of, like, I need an example that I have 5 pens, okay, and in 5 pens I need to give to my friend 3 pens. Okay, so with me I will left with only 2 pens. Okay, so 2 pens I have, 3 I gave, and total is 5. Okay, so what if I lost one? Okay, so if I lost one, I will be left with only 1 pen, and after that with 1 pen I cannot total as and 5, because there would be only 4 because one is lost. So that is data imbalance. The algorithm to check like how the data imbalance is there, or how the data is already challenged to imbalance data. So that is just in machine learning algorithm that is tends to produce an unsatisfactory classifiers which will face the data according to any percentage or any of that. So again, one example more I'll giving to you about the data imbalance, that suppose in a utility fraud detection data, you have to observe the data. So total data observation you have 1,000, correct? And there are 20 fraud observation, and after that non-frauding will be left as, like, suppose we will take the total observation is 100. We have a fraud observation of 20. Okay, we are left with 80. So in that 80 non fraudulent observation would be there, and after that we have an event rate. correct? So that there will be the even rate of 2%, correct? In 100 total observation, we have an even rate of 2%. So the main question arises, like, where is the data analysis then? How we get a balanced data of whatever we need, a decent number of it. Okay, there is a challenges also in the data analysis, that the correlation is there, the evaluation is there of the method that does not require much accuracy, but there would be the imbalanced data, such as the classifier algorithm are there, decision tree is there, then we have logistic regression, we have a bias towards a classes and all. So there how we can change the data in a formulation part in that. So now comes is, what is the significance of bias? Okay, now comes is the significance of bias comes under the error. So what is the bias? Suppose if I'll say that you have two siblings and your mom and dad loves only one child, and that is your sister or brother. So there is bias towards you, correct? That is means like there is something imbalance between. So the bias over here means an error. Okay, we don't have the word bias as in partiality or anything. No, we don't have. We have a word of a bias as an error, which occurs due to the difference between the values predicted and the one same. Okay, and that each of the value predicted by a model would be the original value, which will be used for the prediction in upcoming generation of whatever the data we're gonna form upon in a data set. So it is just in bias. Just remember one thing: bias is an error. Okay, and we need to solve that error, because with the error our project won't work. Correct. So this means that if a model is with a low bias, or then it will predict the training samples properly, and highly biased would be giving us the low priority to the training data. Okay, if it would be a low bias, it will be giving us some more accuracy and more productivity. If it is high, it would be giving us a low priority to the training data. So it is just in high to low, correct? And bias also refers to a systematic error in our model, which means that making the consistent error or any of that. This is called the underfitting in that. So bias also refers to the systematic errors, like how the error is to be systemized, and as an the basic up and down we need to know about, or down to up we need to do. Okay, so that is the systematic errors in that. So in the systematic errors, if it means that the consistency of error is good, so it will give us only and only the meaning of underfitting it is. So what is variance? So variance is an error which defines that the changing in our prediction by a model if we use that different training set or any of that. So it also means like we have a model with basic different prediction in that if we use the different training set in that. Also, like if we have high variance, it means that our model is great at predicting data, and also from the trainings the set, but not as good as it is on the data set. That is the overfitting. Okay, we read about the underfitting, we read about the overfitting. We're gonna use the overfitting and underfitting word in a very soon. But yes, whenever there is a basic formulation of your data, that is the great predicting data or any of that, so that would be as an of your overfitting. So what is the variance trade-off? Okay, in the variance trade-off, it is just a model to have your low bias, okay, or the high variance would be there to show you the high bias. If there is a low bias, there will be the chances of high variance. If there would be the high bias, there will be chances of low variance. Okay, low, high, low, correct? And wherever we need to know the low variance and low bias, we used to know about these graphs in that. So this is the graphical representation, or we can say the illustration of your bias variance trade-off. The first one is the Scott formation row, which is to understand the bias variance trade-off. Okay, and the low bias we have low variance, and after that we have high variance. Okay, and this we have the high bias and we have the low variance. Correct? So we have low bias in that, we have low variance. We have bias and we have high variance. In this we have high bias, we have low variance. High bias, we have high variance. So you can see the scattering of your the data in between the nuclear region of it, or we can see the semicircles or circles of it. Okay. Now, what is overfitting? Overfitting is very good for predicting the training samples, but when it comes to perform, it is poorly on validation and the test samples. It doesn't means like we don't have the proper functionality, but it means like our model has learned too much and it fails generally. Suppose if I'll give the example of myself, if I know I am overconfident. Okay, suppose if I am overconfident and I know 100% of it, and also I know the 150% of the whatever the technologies we have. Okay, so when I used to perform, then I don't know. Okay, I'm getting confused or any of that. So that what happens with overfitting, that if he learn too much it will fail generally. Okay, and this happens due to the less training data. Suppose we are going to tuitions, we are taking a classes. Okay, and we are getting a good marks also in that. So what if like we are learning too much but still we are failing? So this is like when we have a home tutor or anything, or we are having a self studies, so that means like we are not much succeeded. But when we are going to tuitions, getting trained and all, we have good complexities, we score good marks and all. Similarly to this is in like the data. Okay, so the data we use is very much complex data, or it needs a training of it. So training would depends upon how much technologies we use and how much the tradition we have used. Correct. To overcome the overfitting problem, we use the regularization techniques such as lasso, reds, etc., etc. So there, this is the graph of it. So this is the particularly the graph of it, and you can see the sudden change, and after that it is falling below. The most of the data points are under the line. Okay, and wherever we need a certain change, it is the above of it. So the underfitting model is a very poor and predicting the training samples, which means it is unable to capture the underlying essential features on our data. And it also means like it hasn't learned anything. Okay, it is just like people who are not studying after the schools, colleges. So this is just like that. After that, we used this only happens due to the scarcity of the training samples in that, or we use a very simple model. To overcome underfitting, we use adding the more data or to the data set. Correct. This is a particularly a graph to represent the underfitting part. So the underfitting, we use the two variables, that is x and y. One is dependent, one is independent. You can change the axis also, and after that we know like we need to figure out what are the clear data. Okay, suppose if I'll say the upper one is the apple, lower one is your grapes. Correct. So if I'll say the more of the apples are there, more of the, I need to differentiate where the more of the apples are there. Where the line I need to put, like where the more of the one type of apples are there. There is no like grapes are also there and all. No, we need to find out where are the number of chances of apples we are getting. Okay, and also we are like finding out what are the similarities in that function we have. Correct. Like these are the two parts in the overfitting. We use the technologies like regulation techniques, that is lasso, rest, and underfitting we use the complex model, that is the adding more of the training data to our data set. Correct. These are the two parts to find out what is underfitting, what is overfitting, and the condition to use that underfitting and overfitting. Correct. I hope this much is clear to you. Stay tuned for the upcoming videos.